Not gate of logic gates. Not gate in this video. What he says about logic gate? Logic gate, according to your definition, he says that one or more inputs that we have for a logic circuit, for a digital electronic circuit or for a logic circuit, and it is going to have only one output. Such type of gates is what we call it as, or such type of digital electronic circuits is what we call them as logic gates. Okay, generally logic gates will have one or more inputs and it will have one output. Such type of gates are called as, such type of digital electronic circuits are called as logic gates. Then we go to understand what is the next point of your logic gate. What he says about logic gates: logic gates are the fundamental building blocks of digital systems. This is very important point. Okay, if you understand logic gates, you can understand the complex digital systems easily, because these logic gates are used in the entire digital systems. If you have a very huge digital system, the digital system generally is made up of logic gates. Okay, so you will come to know when we go to the chapter number 4, chapter number 5, and further huge circuits to understand. Okay, you people will come to know that digital systems are actually made up of logic gates. Okay, so learning logic gates becomes very important in your primary steps, in your small steps. Okay, so that is why we shall understand the logic gates initially, and then we go about understanding the different combinational logic circuits, sequential logic circuits, and interfacing and all. Okay, so after that, not gate, or gate, and gate are the basic types of logic gates. Very important, you people have to remember this. Not gate is your basic gate, or gate is your basic logic gate, and gate is your basic logic gate. All other logic gates are the combination of the any of the two of these three, or any of these three. Okay, so that is why the three basic logic gates that we have is not gate, or gate, and gate. Keep this in your brain very clearly. Then we go to understand what is not gate. So not gate, generally he says not gate produces an output that is the complement of the input. As we already know, what is a complement? If a is the variable, a complement is going to be a bar. That's it, right? So what is the function of your not gate? Not gate is going to produce you the complement of the given input. If you give a as the input to the not gate, the output is going to be a bar. If you give b as the input to the not gate, the output is going to be b bar. Okay, so that is what your not gate function of your not gate, how it is going to perform. Then we go to understand what it produces. It produces 1 when the input is 0, as I already told you, and it produces a 0 when the input is 1. Okay, so that is what the meaning. Okay, that is what the fun of your not gate. So this is what the logic symbol. We have some input that is given to the input of the not gate. The not gate is written very similar to that of the triangle, with a dot in front of the triangle, and then it gives you the output. This not gate is going to have only one input and one output. That is why not gate, remember, not gate is going to always have one input and one output. Okay, so then we go to understand the boolean expression of the not gate. The boolean expression of the not gate is always y is equal to a bar, wherein y is the output, a is the input. Whatever the input you give, the complemented input is what your output is going to be. That is what he says, y is equal to a bar. If a is the input, a bar is the output, y is the output. Y is nothing but equal to a bar, right? So this is how the y and a, output and input, are related. This is given by a boolean expression. Okay, or this is also called, can be called as logic expression. Okay, the logic expression is always written for logic gates. Okay, then we go to understand the application. Application is very simple. Whenever you want a complemented output of the given digital signal, you can definitely make use of this logic gate, which we call it as not gate. Then we go about understanding the switch equivalent of the not gate. So what happens here, you have some battery source, and as soon as you connect this, current starts flowing through the circuit. Okay, if the switch is closed, it will flow through the only closed switch, and it will complete its path. Okay, if the switch is closed, the output is going to be off, I mean the output is going to be 0. If the switch is 1, the output is going to be 0. If the switch is open, just give me a second, okay, and let me just write it as like, let me select it, sorry. So selector tool, and let us select this and just edit it. So if the switch is open, so then what we call this as, we call this as open, right? So what we should have to write here, I should write open, right? Open. The switch is open. When the switch is open, the lamp is going to glow, lamp is going to be turned on. Okay, so what happens to the lamp is going to, sorry, just give me a second. So what happens here, the lamp is going to turn on. Okay, so yeah, the lamp is going to be turned on. So this is what happens with your logic gate, not gate. Okay, so whenever the switch is open, the lamp is going to turn on. Whenever the switch is closed, lamp is going to turn off. Because here what happens, I'll show you by taking an highlighter. Here the current will start flowing through the battery, and it will go all through this way, and it will go through the lamp, but not the switch. The reason behind it is very simple, that the switch is open, the current cannot flow through the open switch. Hence, it chooses a path along through your lamp, and it reaches the battery back again. So this is what the equivalent of the switch. Okay, switch equivalent of your NOT gate. Okay, so then we go to understand the truth table. Let us zoom into the truth table. Here in the truth table, we say that whenever the input is 0, the output is going to be 1. Whenever the input is 1, the output is going to be 0. This is what your truth table of NOT gate. Then let us go to understand the switching table. As I already told you, whenever the switch is open, the lamp is going to be turned on. Whenever the switch is closed, the lamp is going to be turned off. Okay, whenever the switch is closed, lamp is going to be turned off. That is what happens. Okay, so that is why we say this as the switching table for the NOT gate. Okay, so then we go to finish off this. Okay, let me just come back. This is what it is. I hope you people understood the NOT gate well. If you do have any doubts regarding NOT gate and logic gates definition and all, you people can ask me in the WhatsApp, and even you people can ask me the questions in the application which I have sent you people. Okay, so I hope you people understood this. Have a very good day.